New study suggests we could give Mars a thicker atmosphere, using dust. Wouldn't it be nice if we could just snap our fingers and make Mars habitable? Admittedly, the challenges in the way of inhabiting the red planet are daunting. It's cold, dry, and airless. It is, for all intents and purposes, a dead world. But recently, a team of physicists has concocted a scheme that could warm up the world in a matter of decades. It just takes a lot of dust. Mars does have an atmosphere, but its density is less than 1% that of Earth's. It was once much thicker, but aggressive solar winds blew it into space billions of years ago. Mars also once had abundant water on its surface. We see global evidence of streams and lakes. But when the planet lost its atmosphere, the surface water boiled away into oblivion, leaving behind nothing but a vast planet-wide desert. The near-term plans for humanity's future on Mars amount to nothing more than short excursions and temporary visits. If we want to survive there for longer, however, it might make sense to give Mars a thicker atmosphere. To start, a thicker atmosphere would enable a greenhouse effect that will warm the surface and make future habitation much more feasible. Mars does have two ingredients that make for great greenhouse gases: water and carbon dioxide. But those molecules are frozen either in polar ice caps or just under the surface. To kickstart the release of these molecules into the atmosphere, the planet must first be warmed. It's a bit of a chicken and egg problem. Over the years, scientists have concocted a variety of clever schemes to warm the planet, from crashing comets into the surface to building gigantic mirrors to increase the solar radiance on the surface. But these strategies either require centuries of careful work or engineering projects on a scale far beyond human capabilities. Recently, a team of physicists has developed their own scheme, published in Science Advances, that might just be feasible with our current levels of technology. The plan relies on a specialized form of manufactured dust in the shape of tiny rods, which can be made from small particles of elements found on Mars, such as iron and aluminum. If scattered in the Martian atmosphere, the dust's properties would preferentially allow sunlight to pass through, but simultaneously block infrared radiation from escaping. This creates an artificial greenhouse effect that can quickly warm the planet. The researchers calculate that a release rate of about 8 gallons per second of these nanoparticles into the Martian atmosphere would make the planet warm enough to begin melting and evaporating the subsurface water in a matter of only a few decades. Although the study shows some promising results, it still only looks at purely idealized conditions. While these nanoparticles could be manufactured on Mars from elements found on the surface, it is not a simple task to develop the necessary technology and deploy it to another planet. Another challenge includes the unknown negative effects the particles might have. Like the current Martian dust, the nanotubes could be highly corrosive. And even though the Martian atmosphere would be thicker and warmer, it will not be breathable. Humans will still require a source of air for any surface expeditions. The dust is also highly unstable, breaking down quickly under current conditions. That means it would have to be constantly replenished. If we were to stop production, then within only a few years the pressure and temperature would plummet once more. Long-term stabilization of the Martian atmosphere will require other approaches, but this could be the bridge necessary to make that happen.